Good morning. My name is Pasha, and I will be your conference operator today. I would now like to turn the conference over to our host, Mr. Marius. Please go ahead.
Thank you, Pasha. Hello, everybody. Hello to everyone, and thank you for joining us today. My name is Marius, and I'd like to welcome you to today's Oracle Advisor webcast titled Optimize the Scheduler Jobs Using Turf2 Features and Automated Troubleshooting. Our speaker today is Susan Abraham, who is a Senior Principal Software Engineer. We also have Syed Mohammed Shah, Amir Tadros, and Shekhar Tuduru, who are Technical Support Engineers, joining us as panelists for the Q&A session. We expect today's webcast to last approximately 60 minutes, including a brief Q&A session. This session is being recorded, and at the end of the session, I will go over when and how you can access the recording and the question and answer from the webcast today. Questions can be submitted through me throughout the presentation via the chat or Q&A panel. Your question will be collected and read aloud during the Q&A portion of the call in the order they are received. To aid in question collection, please only submit your question once. If you are listening via voice streaming and lose sound, go to Communicate Audio Broadcast to restart the audio streaming. Should you still encounter difficulties, please dial in to Intercall directly using the number provided in your reminder emails. I've also entered this information into the chat box for you. Any questions that remain unanswered at the end of the session will be transferred to the community where we can continue the conversation. What you see on the screen now is a reminder that this advisor webcast is intended for information purposes only. Any features or functionality described for Oracle products remain at the sole discretion of Oracle. Now, let's get started with our presentation. Susan, if you are ready, I'll hand over the presenter to you.
Hi, yes, Marius, thank you. Hello all, I'm Susan, and I work with Oracle Support. And I welcome you all to our webcast, Optimizing Scheduler Jobs Using the 12.2 features and the automated troubleshooting. So this is the agenda for the day. We'll quickly go through some of the key concepts of scheduler. Of course, in the interest of time, we cannot cover all the concepts, but we will see the ones which are required to understand the rest of our discussion, just to ensure we all are on the same page. And then we'll see the new scheduler features introduced in 12c Release 2, and we'll see the job scheduling in a multi-tenant database. Of course, this is not something new in 12c Release 2, but we still get questions related to the job scheduling in a PDB and how to control and all those. And finally, we will see the guided resolution option available with Jobs and Scheduler. So let's get started with our first topic. What is Oracle Scheduler? As you all know, that is the enterprise scheduling option available with Oracle Database. And the scheduler helps you to schedule your tasks, to prioritize your jobs based on your requirements. You can also manage and monitor your jobs and customize the job execution in a cluster environment. And all these are configured or modified using the DBMS Scheduler PL SQL package. And in the backend, we also have a set of scheduler objects which help us in achieving our desired result. So there are a list of scheduler objects. The scheduler objects are nothing but the schema objects created for storing the job metadata, that is, what, when, and where to schedule. The primary scheduler object is the job. It defines what to schedule, when to schedule, and where to run the job. All other scheduler objects are defined to support the primary object, that is the job. The next one is a program, which defines what to be executed. Of course, you can define that part when you create the job, but the advantage of using program is that you can reuse it. It gives a more modular approach. That means the different jobs can use the same program. Similarly, we have a schedule object, which defines when to execute the job and how frequently you have to execute the job. These two, the program and the schedule, can be mentioned during the job creation, and having those as separate schema objects gives a more modular approach, a more structural approach. And the next one is a credential. The credential schema object, it stores the username and the password pair. And you need a credential while running a remote job or an external job, or even the multi-destination jobs here. Another type of scheduler object is the file watcher. The file watcher objects watch the arrival of a file on a local or a remote location. And the arrival of the file which you have defined will trigger the job. So while you are creating the file watcher object, you can define the location, the name, and the properties of the file whose arrival will initiate the job associated with this file watcher object. The next is another widely used scheduler object, that is the chain, and it helps us to implement the dependency scheduling. So whenever you want to implement the dependency scheduling, you can create a schema object called chain, and here we define the order in which the job has to start and which one, and when to start and when to stop the job. So the chain consists of multiple steps, and you can define the rules and conditions on when to start and when to stop each step. The other two important scheduler objects are the class and the window. So in the job class, you can group a set of jobs, and you can assign priority among these members, and you can assign the set of common attributes to all the members. And most importantly, you can configure or you can define the consumer group, which will help in the resource allocation. And window, which primarily defines the interval of time to run a job. It helps, and you can even mention the resource plan associated with each window. So both class and window together help in controlling the resource allocation to the jobs. Incompatibility is another scheduler object which is introduced in 12C Release 2, where you can specify the incompatible jobs or programs. We'll be discussing more about this in the coming slides. And finally, we have groups, where you can group a set of scheduler objects. So, for example, the Windows group. So with all these wide variety of scheduler objects, we have multiple or different types of jobs. We call it as the job categories. So these are the job categories available in a 12C Release 2 database. So to start with, the basic one, the database jobs, where you execute the DBMS PL/SQL procedures or PL/SQL anonymous blocks. And for these type, we mention the job type as the PL/SQL block or the stored procedure. Next is the external jobs, where you run the external executables. That is the operating system executable that run outside the database. That is external to the database. And here, the job type is executable. Chain jobs, as I mentioned earlier, is a mechanism to enable the dependency-based scheduling. Here you have a set of program objects, and we define the dependency rules on when to start and stop each step. The job type is chain. The next one is the multi-destination object, or jobs, where the job instances run on multiple targets. It can be either database or host. And all these job instances are controlled and monitored from one central database. Another type of job is the lightweight jobs. So you can use lightweight jobs when you have many short duration jobs that has to run frequently. They don't have associated schema objects, and hence the execution and the creation are faster. The job style is lightweight, And for all the other jobs which we discussed, the job style will be regular, where you have regular schema objects and you have the regular logging and all those attributes. Detached jobs is another interesting job category where the job slave spawns the process or the application, and then the process or the application itself will be detached from the scheduler, and it can run asynchronously or external to the scheduler. It's completely independent of the scheduler or the job slaves. And once the application completes its work, it has to log in back to the database and mark the job as completed by calling detached job run as. So for example, if you want a job to shut down your database and then do some activities, you can use these type of jobs. You can have a detached job which can shut down the database, do the activity, then start up the database, and then come back and mark it as complete. So another category is the in-memory jobs, where the jobs are mostly managed in the memory cache. So that's again a new category introduced in 12c Release 2, and we'll be discussing more about this in the coming slides. We have script jobs, which was introduced in 12c Release 1, which can be used to schedule custom scripts. So these script jobs can use different interpreters, such as the SQL Plus, or the RMAN interpreter, or the command prompt, or shell, depending on the interpreter defined while creating the jobs. So we saw a wide variety of job categories and the schema objects available with scheduler. Now, how does Oracle manage to run the job at the defined time or at the defined schedule? For that, we'll see the job architecture. This is the basic pictorial representation of the scheduler architecture. The main components are a job table, a job coordinator, and job slaves. So you have one job table in a database which contains the details of all the jobs defined in the database. And we have a job coordinator, that is our CJQ process, the background process, which reads the job table and then spawns the job slaves according to the schedule. So there is one job coordinator per instance, and the job coordinator will be spawned automatically whenever there is an activity related to the job. So if there is a prolonged period of inactivity, the job coordinator sleeps, and then it will be checking or it will respawn whenever there is an activity. We don't have to define the interval. It's automatically taken care based on the job scheduled in your database. And whenever there is a job to be executed, the job coordinator spawns the job slaves. And the number of job slaves spawned depends upon the number of jobs, the CPU, and few other factors. And the maximum number of job slaves that can be spawned is controlled by the parameter job underscore queue underscore processes. And the default value is 4,000 from 12c Release 2 onwards. The actual job execution is done by the job slaves. And how does it differ in a RAC database? So in a RAC database, again, we have one job table, which is common to all the databases, all the instances. So all the jobs which are scheduled to run on all the instances in that RAC database are logged in the same job table. The view DBA underscore scheduler underscore jobs is built on this job table. And for each instance, there is a job coordinator. So one job table per database and one job coordinator per instance. And the job coordinators, they communicate with each other. And that's how we load balance the job slaves. So in RAC, when you create a job, there is an option to specify the instance affinity or the service affinity. Service affinity can be marked as an attribute. So if you're creating a job with an instance affinity or instance stickiness, then the job will always be run on the same instance. And if you have not marked this, then the jobs will be equally balanced among the instance based on the load. And we recommend you to use the service affinity option so that the jobs can be easily moved to another instance in case of a node reboot. The remaining architecture and the process remains the same. The additional concepts or additional features in the RAC is mostly on the load balancing or the service affinity option. And before we move to the next topic, I would like to talk about the support for DBMS job. We all know DBMS job was the legacy job scheduling option available with the database. It's still available in 12.2, but it's not recommended, as we all know. And from 18.1 onwards, the DBMS job will be de-supported. So we request you all, or we recommend you all, to migrate to job DBMS_scheduler for scheduling your jobs if you're still using DBMS jobs. With this, we can move to the topic of the day, that is the scheduler features introduced in 12c Release 2. There are a few features introduced in 12c Release 2, and they're a bit powerful too. The first one is job incompatibility. So here we can define a job incompatibility, and we can define the jobs or programs which are incompatible, and they will not run together, even if they are scheduled to run together. So the incompatibility can be defined in the programs level or in the job level. So when you define an incompatible job, the jobs defined as incompatible will not execute together, even if they are scheduled to execute at the same time. The jobs will wait for the other one to complete. For example, if job 1 and job 2 are incompatible, then scheduler allows only one of them to run. So if job 1 is running, then job 2 will wait for the completion of job 1, and then the execution of job 2 will be triggered, and vice versa. And there is no particular option for this. It's completely random. And if you want to have a particular order, then you have to use the chain jobs. So how do we do that? The first step is to create the jobs, if it's not already there. So in this example, I created 3 jobs, job 1, job 2, and 3, with the same repeat interval or the same schedule. That is, all 3 jobs will be run on 10, 20, 30, 40, and 50 minutes. So if there are no incompatibility, all 3 jobs, job 1, 2, and 3, can run simultaneously. The next step, we can define or create the incompatibility. So we can use the DBMS_scheduler create_incompatibility to create the new incompatibility. And while creating the incompatibility, you can define the name for the incompatibility, and you can mention the objects. So as of now, you can define a job or a program as the object here. And in this example, I defined all 3 jobs, job 1, 2, and 3, as the objects. And we can verify it using the view DBA_scheduler incompat member, where you can see the objects or the members for this incompatibility. And there's another view, DBA scheduler incompat, which shows the status of the incompatibility. So I've selected 3 columns, the name, whether it's enabled, and the number of jobs running. And you can also add or remove the objects from this list. So I'm using DBMS scheduler remove from incompatibility to remove job 1. So job 1 is no longer part of this incompatibility and it can run independent of job 2 and 3. Or similarly, you can add further objects to this list using DBMS scheduler add to incompatibility. The next feature is resource queue. So when you hear the word resource queue, it has nothing to do with your resource manager or your resources like the CPU or memory or anything. These are the scheduler resource queue. So this is an additional method to control the resource usage of the job. And here we create a scheduler resource queue, and you can just mention a unit. And then you can associate the resources to a job. So we'll see the attributes of this feature. So yeah, as I mentioned, we have an option to define how many resources are required to execute a job. And these resources, please remember, are the resource queue which you created and not part of the usual, the operating system or the database related resources. The resource can be anything. We can just take it as a unit. And when you're creating a resource, the attributes what you can mention are the name and the count. You don't have anything else. You don't have any option to specify anything else. It's just the name and the count. And when you define the number of resources required to execute a job, that particular job will not execute until the required resources are available. And similar to the incompatibility, resource queue can be defined in the job or the program level. So we'll see how to implement this. The first step is to create the resource. So here I'm using DBMS scheduler create resource procedure, and we mentioned the resource name and the units. So I just gave a random number 3 here. So I'm creating a resource, a scheduler resource called resource 1, and we are giving 3 units here. And we can see the details in these views, user scheduler resource or the DBS scheduler resources. So in this example, resource 1 has 3 units and none of them are used because we have not attached this to any other scheduler jobs. And the next step is to associate this resource constraint to a job. So I'm using the same example and I'm associating that with job 1. So we are defining the constraint, that is the job 1 requires 2 units of resource 1. That means if 2 units of resource 1 is not available, job 1 cannot execute. So for example, if I add one more saying job 2 requires 2 units of resource 2, which means job 1 and 2 cannot execute together because we have only 3 resources in resource 1. And that is the functionality of or the advantage of using the resource queue. In a way, if you see, incompatibility can be achieved using the resource queue as well. So if you create a resource with 3 units, and if you define 2 jobs with the same 3 units, which means both those jobs are mutually exclusive, they won't be able to run together because both jobs require the same number of resources or the complete resources of that resource queue. And for a use case, we had a customer request recently where the customer, after doing the data loading, they have separate validation checks. And these validations can be invoked by multiple users with different attributes. So they just create a scheduler job on the fly for doing the validation checks. And the requirement is, if the validation check from one customer is, from one job is happening, the other job has to wait. And if there are no other pending validation checks, our job can continue. And that is the advantage, and this is the place where resource queue can help. You can create a resource queue with any number of units, say 3 or 5, depending on the requirements. And whenever you're creating the new jobs, you can specify the number of units, like 4 or 5 for that job. That means when that job is running, it utilizes 4 units of our resource, the scheduler resource again, and all other jobs which require the same resource will have to wait. And that's an example where we can optimize, where we can use the resource queue to further fine-tune the logic of the scheduling. The next feature is the in-memory job, which we mentioned while discussing the job categories. So here, the jobs access the memory cache mostly, and the access to the disk is very minimal, and hence the speed, or we can see a performance gain for such jobs. So we'll see the details. These are the attributes for this category. As I mentioned, the job uses the memory cache with very minimal disk access, and the metadata, the details of the jobs, like the metadata or the job run details, are not stored in the dictionary, and hence there is no logging. So all the in-memory jobs are associated with a class, default in-memory job class. And if you see the attributes of this class, you can see there is no logging enabled, and hence you will not be able to check the run details of an in-memory job. These in-memory jobs are recommended when you want to create jobs and execute it in a short period of time. The job creation is very quick because there are no schema objects associated with this, and there are no disk access, and the job, hence both the creation and the execution are pretty quick compared to the regular jobs. There are 2 types of in-memory jobs. One is the in-memory runtime and the in-memory full. In case of in-memory runtime, a minimal metadata, I would say that just the job metadata is stored in the disk. So there is a minimal footprint on the disk, and hence the jobs are persistent and repeatable. You can specify a repeat interval with in-memory runtime jobs. So for creating the in-memory runtime, the job style is in_memory_runtime. It's different from lightweight, it's different from the regular type. This is a third category or third job style called in-memory runtime. And the other category, another type of in-memory job is the in-memory full. In this case, the job is completely cached in the memory. The metadata is not stored in the disk, and hence it's a one-time job. After the execution, the job will be automatically dropped. That means you will not be able to specify a repeat interval along with in-memory full jobs. The job style in this case is in_memory_full. So we'll see a quick demo. I have pre-recorded the demo for the interest of time. So I'm logging in as a custom user, and I'm creating a test procedure, which is just going to insert value to a table, and I'm introducing a sleep of 180 seconds, a 3 minutes delay, so that we can see the execution. So I'm creating a job 1, with a repeat interval to run on every 10, 20, 30, 40, and 50 minutes, using the same test procedure. So I'm creating a very basic job to show the incompatibility and the resource queue. So I'm creating 3 jobs with similar metadata, similar job action, and same repeat interval. That means if there are no incompatibility or no other constraints, all 3 jobs can execute together. So I'm checking the details using DBS scheduler jobs, And we can see all three jobs, job 1, 2, and 3, are scheduled to run at 4:50 p.m. So we'll check the date. It's around 4:42 at this time, and we have to wait till 4:50. So fast forward, we are already at 4:50, and when you check the status using scheduler, DBA scheduler jobs, you can see all three jobs are running together, and that's how the schedule was. They were expected to run together. Now let's create an incompatibility. So see, the jobs are still running, and I'm trying to create an incompatibility with the name new underscore incompat, and adding the three jobs, job 1 and 2 and 3, to this list. And since the jobs are running, you get an error saying the job is running and you cannot add an incompatibility. So you cannot add an incompatibility when the member is already in the execution stage. You'll have to wait till the job completes. So I'm going to wait till the job completes. Yes. And now we can see the next scheduled time, that is 5:10 p.m. for all three jobs. And now I'm creating the same incompatibility. Incompatibility for job 1, 2, and 3, and we can query the views. The new underscore incompat incompatibility is created, and there are no jobs running now. And we can see the members using the view DBA scheduler incompat member, and we can see all three jobs, job 1, 2, and 3, added to the new underscore incompatibility. So now we have to wait till the next execution time. We'll fast forward. We're already at 5:10, and we can see, no, it's scheduled to run at 5:10. All three are scheduled to run at 5:10, and we did a fast forward, and we are at 5:10 already. And when you see the number of jobs running for this incompatibility, we can see 1. So in spite of the number of objects added to this incompatibility, at any point of time, you can see a maximum of 1 job running at any point. So if you have 5 jobs or 10 jobs added to this incompatibility, at any point, at max, or at any point, only a single job can execute and all others has to wait. So we'll see the status using DBA scheduler jobs. So when you check the status, you can see job 2 is running and job 1 and 3 are waiting. And as I mentioned, it's completely random order. The next execution, you may see a different order in which the jobs are executed. There is no, unless there is a priority. If there is a priority associated with these jobs, then yes, you can control the order at least to some extent. But otherwise, it's a completely random order in which these jobs are executed. So in the next execution, that is after 3 minutes, once job 2 completes, job 3 started, and job 2 is scheduled for the next runtime, that is 5:20. And after 3, we can see job 1 starts its execution. And I'm dropping the incompatibility using DBMS scheduler drop incompatibility. So we'll see the next feature, that is the resource queue. We'll see how we can implement that. So I'm using the same jobs, job 1, 2, and 3, which we used for the previous check. And I'm creating the resource here. So here I'm creating 2 resources, 2 scheduler resources, resource 1 and resource 2, with 3 units each. So it's just simple. It has nothing to do with your available CPU or I/O or memory. The only requirement is it's completely based on your business requirement, the logic on how you wanna schedule the jobs. So after creating the resources, we can verify using the user scheduler resources. So there are 2 resources with 3 units each, and none of these units are used now. Now we will add the constraint to the jobs. So please pay attention here. The way I have defined is job 1 requires 2 units of resource 1. Job 2 requires 2 units of resource 1 and 1 unit of resource 2. So job 2 will wait until 2 units of resource 1 and 1 unit of resource 2 is free. So it clearly indicates I cannot run both job 1 and 2 together. Why? Because in resource 1, we have only 3 units. Job 1 requires 2 units and job 2 requires 2 units. So these two cannot be run together. And for job 3, have defined 1 unit of resource 2 and 1 unit of resource 1, which means job 3 can execute along with job 1 or job 2. It's fine. It's not overlapping. There is no overlap in the number of resources. It's fine. We can have both job 1 and job 3 at a time, or job 2 and job 3 together. So this is how you decide how to create or how many resource units you require. It's completely based on your business requirement. So we'll see how this works. So I'm adding this constraint, and it's done. So we can verify the same using user scheduler resource constraint. So we can see job 2 requires 1 unit of resource 2, job 3 requires 1 unit of resource 2, job 3 requires 1 unit of resource 1, and job 1 requires 2 units of resource 1, and job 2 requires 2 units of resource 1. Now we'll see how the resource allocation is. So at this moment, the unit used is still 0 because none of these jobs are currently executing. So you will not see a number here that is in the units underscore used field until the job is executing. So just because we added a constraint doesn't mean we are utilizing those resources. We are utilizing the resource only when the job executes. So we'll wait for the next execution, and we can see job 2 and 3 are running, and job 1 is waiting even though it's scheduled to run at the same time. And that's very much in line with the way we have defined the resources. And once job 2 and 3 completes, job 1 will start its execution. And when it's executing, we can see the number of units used for each resources. It's in line with how we have defined the resources. Job 1 is completely utilized. We have 3 resources and all 3 are utilized. And job 2, we have still 1 unit pending. And after the execution of job 2 and 3, we can see job 1 is executing now. And the corresponding resource utilization is updated in the views. So for just, we can verify in the scheduler jobs status, all are done and scheduled for the next executing time. And I'm just dropping the resource and the jobs for the cleanup purpose. So now, coming back, we can move to the next topic, that is scheduling jobs in a multi-tenant database. So jobs in CDB or CDB or the multi-tenant is almost similar to the jobs in a non-CDB. There are just minor changes made to adapt the scheduling DBMS scheduler to the multi-tenant architecture. The first one is the job queue processes. So we can set the job queue processes in the CDB and in the PDB level. the default value of job queue process is 4,000 from 12c release 2. So when you set it in the CDB level, we are controlling the number of job slaves that can start, that can be spawned in that database. So the value can be from 0 to 4,000. And when you set the job queue process parameter in the PDB level, the meaningful values are either 0 or 4,000. You cannot set, or the values in between doesn't have any meaning at all. So when you set it to 0, no jobs can be run in that particular PDB. So if you have 3 PDBs and if you set the job queue process to 0 in one of the PDBs, none of the jobs scheduled for that PDB will work. And when you set it to 4,000, all the jobs can be executed. And 4,000 is the default value. Another point is all the scheduler global attributes need to be set on each PDB. As of now, we don't have any option to specify multiple PDBs while setting a global attribute or while creating a job. It needs to be done in each PDB. And the last one is related to the scheduler windows. We saw scheduler windows is a means to specify the resource manager plan, that is to control the resources. And in a non-CDB, we can have only one scheduler window open at any point of time. In case of a CDB, we can have more than one. That is, in a CDB level, we can have one window, and that is used to control the resources among the PDBs in that container database. And within a PDB, we can have another window, which is to control or allocate the resources among the consumer groups within the PDB, which means we can have more than one scheduler window open in the multi-tenant database, but only one in CDB level and one per PDB. And there are minor changes in the job architecture or the job components as well. The job coordinator in this case checks the jobs which are scheduled in the PDBs as well as the CDB dollar root. So it checks this job for all the PDBs, and it gets the list of jobs to be executed and spawns job slaves for executing the job. And the job slaves, after spawning, switches to each respective PDB for execution, because you can access all the schema objects within the PDB only. So the job slave switches to the PDB. And it's a job coordinator which opens the windows in both the PDB and the CDB. The dictionary changes are similar to the other features. You have a container ID added to the views, and you have a CDB dollar view similar to the DB underscore view. And as you all know, the CDB dollar view in the CDB level contains the details from all the PDB, and in a PDB level, it contains, the output is similar to that of a DB underscore view. So we'll see a quick, another pre-recorded demonstration. Yeah, here I have 3 connections. One is to the CDB dollar root as sys, and PDB 1 and 2 as, you can see the container ID, PDB 1 and 2 as a local user here, as a common user, sorry. So in this CDB, I have 2 PDBs and a PDB dollar seed and root, so we have 4 containers. And ORCL PDB12 is marked as PDB2 here, and ORCL PDB11 is marked as PDB1 here. So I'll quickly go through this. I'm taking the user and the container ID, just verifying the connections. So here also it's connected as a local user, as a common user with a container ID. And when you check the job queue process here in the CDB dollar root, we can see it's 4,000, that is the default value. And I'm coming back to PDB1. I'm sorry, it's a bit fast in the interest of time. So here I will create a table the job test, and I'll create a procedure to insert value that is the sys timestamp to this table. And I'm going to do the same in the PDB2 as well. So here again, I'll create the same table and the same job with the same name. Coming back to the root, and when I'm checking the status of the scheduled job, it's scheduled on both and the same time also. Checking the time, it's around 4:10. You have to wait for 2 more minutes for this execution. Doing a fast forward, we can check the status. Yeah, it's the time. Because when we check the status, job 3, the job in container 3 has completed. So I'll go to PDB2 and check the status, or we'll check the entry from job test, because with every execution there will be a row inserted to the job test. So we have 2 rows in job test, and I'm checking the job test from PDB1. Please note the DB link over there. So I'm connecting to PDB1 and then checking this output. And now I'm disabling the job execution in PDB2. So I'm setting the job queue process to 0 here. We'll go back to root and we'll see the parameters, the job queue process parameter. So we can see it's set to 0 in container 4, that is the PDB2. That means the job is disabled in PDB2. We'll verify using the output from job test. So we'll wait for a couple of executions. You know, it's scheduled in every 5 minutes, so we'll wait for the next execution. And then verify the output in job test. I'm not able to show you the execution status because there is no delay in executing the job. It's pretty fast. So we'll see the output from job test to verify the execution. So from job test in PDB2, we have only 2 entries. That means the job has not fired after those 2 entries, after those 2 executions, sorry. And when you check in PDB11, we can see additional rows there. That means the job execution continues in PDB1, that is ORCL PDB11, the container ID 3, but it's disabled in the local job test. That is the job, the table local to the PDB2. And this is how you can control the job execution in a PDB. I'll move on to the last topic and the most important one too. That is the guided resolution option available with the scheduler. So you all might have seen when you create a service request, you are presented with a guided resolution which help you to narrow down to the problem, and you are provided with a solution too. And if the solution is provided, please remember to implement the action plan. And in case if the solution doesn't help, or if your issue is not covered in this guided resolution, you can create a service request, and while creating, please upload the diagnostic data listed in the SRDC document, that is the SR data collection document. And please remember not to change the file names listed in the SRDC document. If there is a spool output, please do not change the file name. There is some additional logic added to the spool name, and we do have an automated file validation which happens in the backend. And the next step will be an automated problem signature analysis. And specific to the jobs and scheduler issues, the SRDC output incorporate recommendations based on the common or the configuration issues. That is, for example, I've run the SRDC related to the email notification issues. So a customer complained that the email notification is not running, and when we ask to execute the SRDC, it gives the recommendation based on the configuration. So in this case, the AQTM process parameter is not set properly. The email server attribute is not set properly. the email sender is not set properly, and we are giving the recommendation as well. And there are no jobs created with the email notification. And these recommendations are for the customers, and there is a report or a spool output created for support, which gathers the data. So it's something like this. So you can see it checks the dictionary views related to this particular feature or aspect and connects the data for the support. It gives the recommendation as well as the complete data. And now comes the million-dollar question you all might be having. Can I rely on the suggestions provided by guided resolution or automation? My answer is yes. We can absolutely rely on the suggestions provided by the guided resolution or the automated troubleshooting. Why? Because these signatures or the solutions are compiled by the subject matter experts, and it's based on the research on hundreds of service requests. The guided resolutions are highly tested, and we continue to evolve as we incorporate the issues and the feedbacks from you. Please use the Give Feedback button every time you consider your issue should be incorporated in the flow. With that, we come to the end of the discussion. So to summarize, we revisited some of the key concepts of the scheduler. We saw the scheduler features introduced in 12.2, and we saw examples and how to use them to optimize your job scheduling. And we saw how to schedule a job in a multi-tenant database, and most importantly, we talked about the automated troubleshooting for scheduler issues. I hope you enjoyed the session, and thank you for your time. Over to you, Marius.
Thank you, Susan. We are going to open the Q&A in just a moment. Please use the Q&A panel or the phone line to ask any questions. You can send the questions via Q&A panel on the Webex screen or press *1 if dialed in on the phone. While we pause to collect your questions, I'd like to share some helpful information. We'd like to invite you to stay connected with Oracle support via our various social media channels listed here. We have the Oracle database communities where you can post your questions and converse with subject matter experts and peers from other companies. My Oracle support blogs where you can keep informed about our priority announcements. Let's quickly cover each of the elements and their supporting icons that you will see throughout your learning experience working on My Oracle Support Portal and Cloud Support Portal. Online help documentation can be found from the help link on most pages on the portal pages. With the Oracle Support Essentials webcast, you'll learn how to best use the support portals, My Oracle Support and Cloud Support Portal, and provides tips and tricks on how to effectively work with Oracle Support. Oracle Support Video Series provides you with a repository of detailed training videos. Oracle Support Accreditation delivers a targeted learning experience to increase your expertise with support portal core functions and product-based support tools. As an Oracle Premier Support customer, you have access to a wealth of powerful resources to help you proactively manage your business. Use document 432.1 to get proactive and prevent issues and to contact the team responsible for proactive programs. You can also get a complete view of upcoming events with the Get Proactive Events calendar. The Proactive Support team sponsors a wealth of proactive support activities, including advisor webcasts like this one. You can get a complete view of upcoming events and activities with the Get Proactive Events calendar shown here. This calendar is automatically updated to include currently scheduled advisor webcasts, user group session, most essential trainings. You can filter the activities according to the Oracle software product most relevant to you. Look at the documentation for more details, but you can also set up calendar to display based on your time zone, and all of the event start time will update accordingly. Now we're going to open up for questions. Operator, are there any questions?
If you would like to ask a question, please press star followed by the number 1 on your telephone keypad. Again, it's star 1. At this time, there are no questions. I'm sorry, we do have a question from the line of Justin Jose.
So would you please share this document once you complete this session?
The document will be posted in the communities in 48 hours after the presentation is over, of course.
Oh, okay, thank you. So another one is the job category. So the job category you define, it's kind of a job set. It's a so we can define a number of job category, right? And the job category we define, it's kind of dependent jobs together.
Okay. I'm not sure whether I understood the question properly. The job categories are fixed. It's the available job categories are the ones which we discussed. Those are fixed. But you can define either of these. You can use either of these while creating the job.
Yeah, okay. So here my question is, if we are considering about a batch jobs, so that having some n number of jobs that is mutually depending, and there are some dependency and predecessor jobs and the successor jobs, and so we need to align those jobs according to the workflow of that particular jobs, and especially in batch jobs. So some jobs it is independent that can do independently. So I would like to know whether we can customize these jobs, the job category based on different type of jobs.
Okay, now I understood the question. Thanks for explaining it. Yes, you can use the chain jobs in this case. You can define the chain which gives the order. So you can say once job 1 is completed, go to job 2, and if job 1 is not completed, go to job 3. You can define the rules the way you want. So chain jobs or even base jobs be the best way to implement this. Thanks for the question.
Okay, so yeah, so we can include the exceptions if any error or the job is failed, right?
Yes. You can do that using chain jobs.
Okay, thank you. Yeah. So this one more question. This is any alternative to because we have some job scheduler softwares available, Unicenter TNG and AutoSys. Is it replacing for those kind of job schedulers?
This is something provided by Oracle for the Oracle database. So I would say it's a replacement of DBMS jobs, an enhancement for DBMS job with a lot more features, but not for
because
any other
I could
job
see you mentioned it can handle both the DBMS jobs like a PL SQL blocks or anonymous blocks, and external jobs like Unix shell scripts or bad jobs in Windows, right?
DBMS job, that piece of code is not being enhanced from many years. It's available only for the backward compatibility, so it's something like what you had in 9i is still continuing. From 10G, when we introduced DBMS scheduler, we introduced with not many more additional features, and if you see, including the scheduling option, the repeat intervals, and there are many options which is there in DBMS scheduler and not in DBMS job. So all the categories which I mentioned, including the job chains which we discussed, are not available in DBMS jobs. It's there only with DBMS scheduler.
Okay, yeah. So I'm just asking you. Yeah, so I'm just asking you that scheduler, so it can handle both the DBMS jobs and it can handle external jobs like Unix scripts jobs, right? So it can replace, so because those the job scheduler vendors, they can do both, and so I just ask you, okay, we can integrate all our programs and everything from cron jobs, or if it's running from crons, that is especially the Unix level program, but it is pointing to the database. So I just ask you whether we can point all these scheduler jobs. It can schedule from our scheduler, Oracle scheduler.
Yes, exactly. All the report, like all the cases which customers reported, all the use cases are, I would say, included in the current categories. And the resource queues and all those were included with the new additional requests from the customers. And we, as of now, I would say most of the features, if not all, can be handled by DBMS scheduler. We do have the different varieties, as what I told as the job categories, which can cater most of the requirements, if not all. Yeah.
Okay. Thanks
for the question.
Thank you. We have a written question. What exactly does the resource unit contain? What does resource unit refer to?
Yeah, the resource unit is something what you define. That is just a unit in the scheduler queue or the scheduler resource queue which you mentioned. It has nothing to do with the OS resources or the database resources, or it's not going to consume any additional resources. It is just a resource which you can define, and you can use the same thing to control the other jobs. So we didn't want to control the jobs based on, say, memory or a CPU. We are creating our own resource queue. It is nothing. You can just think as anything. That's it. And we are using that option to control the execution of the jobs. So it, in short, it doesn't mean anything, and it's not going to add any additional load on your server or a database.
Thank you. Another written question will be, what happens with materialized view using the old scheduler when you do an upgrade or imported schema built by an export out of an Oracle 12.1 or later?
Yeah, the materialized view is still using DBMS job, but there is an enhancement that from 18.1 onwards, it will be using DBMS scheduler, and there is an enhancement and which is already implemented. So yeah, as of now, it uses DBMS job, but yeah, going forward, it will be migrating to DBMS scheduler.
Thank you.
There are no further questions at this time.
Thank you. Another written question that we have is, in 12.2, has MView jobs been switched to job scheduler?
Yeah, I just answered the same question. Yes, it's not a switch to scheduler. It will be switching from 18.1 onwards.
Thank you.
It still uses DBMS jobs. Yeah. Thank you.
Another written question, is it possible to get these job scheduling features using DBMS job?
No, we won't be able to provide these features using DBMS jobs now. As I mentioned, we are not taking any further enhancements. In fact, the enhancements for DBMS jobs have stopped from past few years. So for all these options are available only with scheduler, and all the further enhancements will be made only for DBMS_scheduler. Thanks for the question.
Thank you. Another question that I have seen right now is, the 12.2 documentation mentions the value for job queue processes as 1,000, but you mentioned it as 4,000. Which one is correct?
Yeah, thanks for the question. So I could reiterate that, yes. The default value for job queue process from 12c release 2 is 4,000. And there is a documentation bug, which we have already informed, and that will be updated in a while, yeah. But yes, the correct value is 4,000. And we already saw that in our demo as well. The documentation will be updated. Thank you for that question.
Thank you. Are there any other audio questions? Operator?
As a reminder, if you would like to ask a question, please press star followed by the number 1.
Okay.
At this time, there are no further questions.
Thank you. We have another written question. How do we create similar jobs in multiple PDBs? Is there an option to create a job in multiple PDBs in one go?
Yeah, as of now, we don't have any option to choose multiple PDBs when you're creating a job. You have to do that manually by logging into separate PDBs, and you'll have to create the jobs. All the schema objects are specific to the PDBs, and hence, in this current version, we don't have any option to create a job or even specify or even set an attribute in multiple PDBs.
Thank you. Another